In 2020, combined analyses of polarization data from the Plan mission of the European Space Agency and the Wilkinson Microwave Anisotropy probe of NASA revealed a possible systematic deviation in the polarization angle of the cosmic microwave background, corresponding to a global rotation of approximately 0.35 degrees. This initial detection, conducted independently by research groups in Japan and the United States, exhibited limited statistical significance but introduced a profound hypothesis: the existence of astropic cosmological birefringence. Between 2020 and 2025, this anomaly became the focus of extensive investigation by multiple international collaborations, employing high-precision polarization measurements from the Atacama Cosmology Telescope, located at an altitude of about 5,000 meters in the Atacama Desert, Chile, and from the South Pole Telescope, situated in Antarctica. In 2024 and 2025, new independent analyses, incorporating refined optical modeling of instrumental response, meticulous calibration procedures, and systematic error suppression techniques, robustly confirmed a global mean polarization rotation between 0.3 and 0.4, achieving statistical significance exceeding 7, well beyond the conventional threshold for physical discovery. Crucially, the observed effect was found to be astropic, independent of sky direction, uniformly affecting radiation arriving from all observable regions. This astropy decisively rules out conventional astrophysical or instrumental explanations, including local magnetic fields, galactic dust contamination, Faraday rotation, or residual instrumental systematics. The data therefore point toward a fundamental cosmological origin. Within this empirical framework, a natural theoretical interpretation arises from the helicoidal solitonite field model, as developed in a helicoidal solitonite field model of particles in emergent space and time. In this model, physical space is not treated as a passive geometric background, but rather as an emergent dynamical structure arising from a fundamental helicoidal field endowed with intrinsic topological vorticity. The propagation of electromagnetic radiation through this helicoidal medium induces a cumulative geometric phase shift, originating from the coupling between the photon spin and the global helicity of the underlying cosmological field. This spin-helicity interaction generates a systematic rotation of the polarization plane, producing precisely the astropic cosmological birefringence now observed. Mathematically, this mechanism is naturally described by an effective topological coupling of the Chern-Simons type, emerging dynamically from the field topology, without requiring the postulation of exotic action-like particles, Lorentz-violating extensions, or ad hoc modifications of the standard model. The extremely small observed magnitude, of ordered fractions of a degree, follows naturally from the very weak local helicity density, whose effect becomes detectable only after integration along cosmological path lengths approaching 13.8 billion light-years. Thus, the observed rotation reflects a cumulative topological effect rather than a local interaction. These results suggest that the universe exhibits a deep global helicoidal structure, whose physical signature manifests directly in the polarization of primordial radiation. In this sense, cosmological birefringence may constitute the first direct observational evidence of the helicoidal topology of spacetime itself, as predicted by the helicoidal solitonite framework.